with our team to study the influence of the Sesan II reservoir on the water quality of the tributaries going into the Mekong River. So behind me is the Sesan II dam, and this is a dam that was just in operation the last few years. And our goal now is to go onto the reservoir and to measure water quality in the reservoir. That includes particles of sediment that are very important for contributing nutrients to the fishes of the Mekong. We've loaded our equipment on the boat, and now we're going to take this boat onto the reservoir, and we're going to go to two different locations on the reservoir. The first location is closest to the dam, and there we'll collect our samples for water quality and also put special probes into the water so we can take measurements of temperature, oxygen, and carbon dioxide gases. And then we're going to come back to the second site on the reservoir, and that's a site that's further upstream on the reservoir where the river inputs into the reservoir. And there we'll also put more sensors that we'll deploy into the water to measure water quality changes. We're now here on the Sesan Reservoir at our first sampling site, and we're here with our team of Cambodian and US scientists. On the Cambodian side we have Boone, Samal, and Kim San, and on the US side we have Teresa and Bonnie. And in the next hour we're going to install probes and now collect water quality profiles from 0 meters all the way down to 20 meters in the water column.
Okay, this is a sake dish we use to measure the clarity of the water, basically to measure, to understand the particles in the reservoir. So we monitor the reservoir over time. We can see the change in. This is the water profiler. It basically collects data on temperature, oxygen, and chlorophyll A. Oh, almost 20 meters. This is a water sampler, and we use this to take sample of water from different depths of the reservoir. So we will sample at 5 meter, 10 meter, 15 meter, and 20 meter depth.
Today we're going to be working with the ADCP, which stands for Acoustics Doppler Current Profiler, and this device will help us determine the velocity of the river, so how quickly the river is flowing, and also the depth of the river. And both of these variables can be used to help calculate the river's discharge. So we're going to do a transect across the river, and we are using a program that we are running on this tablet that will communicate to the transducer on this float so that we can collect the data.
So after we collect the water, we are going to take it back to our makeshift hotel laboratory where we will filter the water for nutrients of nitrogen and phosphorus, and we'll also measure temperature and oxygen within bottles. And we'll incubate those bottles or place them in light and in dark settings for the next day to 5 days, and we'll measure the amount of algae growth in the bottles and the amount of bacterial growth within the bottles. Some of the results of the study will be collected and processed here in Cambodia, and other results will be processed in the United States, and then together we'll compile the information and then present it back to our colleagues here in Cambodia.